What if I told you there is a crap strategy that wins more often than it loses and has one of the lowest house edges in the entire casino? But there's a catch. Today, we're going to the dark side with the 3 Point Dolly. This is dice data. I run simulations of crap strategies and analyze the results in ways that humans can understand without needing a statistics degree. The 3 Point Dolly was named by the Wizard of Odds. I'll link to his website and his video on the topic in the description below. The aim of this strategy is to make a don't pass and 2 don't come bets until you have covered 3 numbers. You can optionally lay odds up to the table maximum, but in this video, we'll be managing the bankroll by laying only single odds. The don't pass bet is essentially the opposite of the pass line bet. You're betting that the shooter will 7 out. On the come out roll, the don't pass will win on a 2 or 3, lose on a 7 or 11, and push on a 12. Once a point is set, you can lay odds, which pays according to the true probabilities of the dice and carries no house edge, just like taking odds on the pass line. The amount you win depends on the point, and in most casinos, the minimum you can lay must return at least the table minimum, which for us is $15. The 4 and 10 pay 1 to 2, so to win $15, you have to lay $30. The 5 and 9 pay 2 to 3, so to win $16, you have to lay $24. Now, in this one, the proper bet is rounded up since the casino doesn't work with exact change. And the 6 and 8 pay 5 to 6, so to win $15, you have to lay $18. The don't come bets work in exactly the same way. They win on a 2 or 3, lose on a 7 or 11, push on a 12, and otherwise move to their number, and then you can lay odds on them. Let's run the simulation. I'll simulate 100,000 sessions playing through 10 shooters, so we'll end up with 1 million shooters total. That's 8.5 million rolls, or 85 rolls per session, which is exactly what I expected. At a table doing 40 rolls per hour, that's just over 2 hours of play. From the casino's view, they saw over $181 million in action, with a house take of $1.3 million. That leads to a house edge of 0.723%. Let's see how we did. 52% of the sessions won any amount of money. Only 156 sessions pushed, which means they didn't win or lose any amount of money. They ended exactly where they started. And almost 48% of the sessions lost money. So this strategy does win more often than it loses, but here's the catch. The downside is bigger than the upside. When you lose, you can lose more than you might gain when you win. Let me explain. In the 100,000 sessions, the most lost was $1,000, while the most won was only $764. Here's the histogram of session outcomes. 32% of the sessions ended with a win between $1 and $200. Almost 60% of the sessions ended between plus and minus $200. 90% ended between plus and minus $400. And 98% ended between plus and minus $600. These are very similar results to the 3 Point Molly, with just a little shift towards the greater losses that come from playing on the dark side. If you would like to play this strategy at a $15 table, it would be good to know what bankroll you might need to be able to survive for these 10 shooters. To answer this, let's look at the most any player was down during their session. Only 2 out of 100,000 sessions never fell below their original bankroll. 7% were down only $100 or less at their worst moment. Almost 3 out of 4 players were never down more than $400. And 99% were never down more than $900. So playing this strategy with $900 at a $15 minimum table means you have less than a 1 in 100 chance of going bankrupt before you finish the 10 shooters. There's a variation of this strategy where you don't replace the don't come bets if you lose them, and this is going to limit your investment for each shooter. If you'd like to see that analysis, leave me a comment below. If there's interest, I'll modify the simulation and make another video. If you prefer to stay on the light side, check out my video on the 3-point molly here. Good luck at the table, and thanks for watching.